Hey Tube, welcome back. I guess we finished the system design of WhatsApp. Today we will start talking about some improvements in our design and some problems that we need to address. So, in your system design interviews, when you've been asked about designing a chat system, there's a question that will come in your system design interviews. I would say 100%, which is what should we do, or basically how could we address the chat server failure? Okay, so because if we, as we said before, this is how actually chat 101 happening. But what should we do if we have one server has failed? What how we can manage this? So when the client is connecting to server A and this server is failed, what should we do? How we can manage this problem so the user doesn't recognize that there was a problem happening and there is no outage, because availability and low latency is pretty important in our system. The first thing that we can think about is redundancy, which something we already did. We add multiple servers, like we add multiple chat servers. Like the diagram shows here, as you can see, server A and server B under chat server. This is the most fundamental step. Instead of a single point of failure, you have multiple identical instance of chat servers. Redundancy, basically we add like n plus one. Like you generally provision n plus one servers, meaning that you have enough capacity to handle the load even if one or x servers have failed. Next, that might solve our problem is the load balancer by itself. The load balancer will make health checks. Basically, the load balancer will continuously monitor the health of each chat server. If a server become unresponsive, like fails in its health checks, the load balancer immediately removes it from the pool of active servers. Basically, and after that, we will make like the load balancer will make traffic redirection, like all new incoming connections and existing connections, if supported by the load balancer and the client reconnection logic, are automatically routed to the remaining healthy chat servers. This prevents a single server failure from taking down the entire service. Next, we now talk about how we make the reconnection of the client. So here, this is where the distinction between stateless and stateful chat servers become crucial for recovery. If we have a stateless chat server, basically a truly stateless chat service would not store any user session information in its local memory. All necessary status will be in Redis or in a distributed database. And you can see here we have all the data that we need in distributed database. So the recovery will be like if server A crashed, user's WebSocket connection is broken. Basically, the client is designated or de-assigned to automatically attempt to reconnect. The load balancer will redirect this reconnection attempt to a healthy server. For example, it will be server B. Server B then uses the user connection cache to determine the user's one is now connected to it, basically, and can resume the session. The benefit of this one, we have minimal impact on the user. The reconnection might cause a brief connecting message, but no session data is lost from the server's perspective as it's externalized. This is highly resilient. In terms of stateful, I'll not talk about stateful because it will be we will need to talk about about a lot of things. So since we have a stateless here, so we just continue with that. In terms of the message durability, actually the message queue will help in that, because the message queue is critical here. When a message is sent by user one or the client, let's say assume this is user one, it's first published to the message queue before being delivered to user two or the other users. This means even if the chat server crashes after publishing the queue but before confirming delivery to user one, the message is saved in the queue. After that, the message will be sent to the message storage service. Basically, will eventually pick up and persistent the message in the message DB. The message DB by itself, basically, this database, like Cassandra in WhatsApp case here, will stores all messages persistently. This handles like offline delivery. Like if user two, for example, of the other user that our client wants to send message to was offline, when the client send the message, the user two's client can fetch all missed messages from the message DB upon reconnecting. And what next do we talk about when we have a server failure? I guess when you talk about user connection cache, because this is a crucial for routing. Basically, since we're using a centralized connection state like Redis, the connection cache here will basically it is basically Redis, which is basically a high speed distributed cache that stores users which is connected to which servers. We can make like a fast lookup, like when your server A needs to send messages to user 2 or any other user, it will quickly checks the user connection cache to find out which server user 2 is connected to. This is a faster and the fastest than querying the full database. What else should we talk about? I guess this that's it. When in terms of what should we do when the server one server is failing. And yeah, that's it for this video, and see you in the future.